In this lesson, we're going to examine the types of solutions that systems could have. So I'm not so much worried about what the solution is. I don't need the POI. I'd much rather know what kind of POI I have, whether there is one or not even. So there's three different situations we can come across. Number one, there is no solution. Your two lines never cross. In other words, they are parallel to each other. So they have the same slopes, both 2/3 in this case, but different y-intercepts. If that's true, well, they'll never cross. You don't have to worry about solving it because they can't be solved. Situation two, they intersect at a single point. The most obvious way to tell this is that they're going to have different slopes. If you have a different slope, they'll have to meet somewhere. It might be a nice spot, it might be a messy spot, it might be way off the graph somewhere, but they'll meet as long as they have different slopes. In the third situation, which is kind of the tricky one to tell, is that the two lines intersect infinitely. In other words, they're on top of one another. And this can be kind of difficult to tell sometimes if they're in different formats in particular. So in this first equation here, we got y equals 2/3 x plus 2. But the second one is in a different format. However, if I rearrange this, put it into mx plus b, and divide everything by -6, I end up with 4/6 x plus 2. But 4/6 reduces to 2/3. So even though it didn't look like it initially, it's actually the same equation. It's just a different format of that equation. And as I said, that one can be kind of hard to tell at times. So we're going to have to work on some of our rearranging skills, possibly. So three situations. They don't meet, they meet once, or they meet everywhere, infinite solutions. So we're going to look at some of these situations. I don't really need to do a lot of math if I recognize some things. Yeah, so without graphing, I don't want to know the answer, determine the number of solutions to each system. So, options. One intersection, no intersections, or infinite. So if we look at example A, the first thing I want to look at is my slopes. My slopes are 3 and -3. In other words, one line's going up to the right and one line's going down to the right. Well, those are going to have to meet somewhere. There's one solution. And I know that because we have different slopes. That's the easiest way to tell. Let's look at this second example. And again, let's look at our slopes first. So I got -1/2 and -1/2. Well, -1/2 and -1/2 mean the same thing. And that would be the same thing as this too if you wanted to see it. So the fact is we have the same slopes. So my two lines are at least parallel to one another. The question is, are they on top of one another? And the fact that I have different y-intercepts means that they're just parallel. So if they're parallel, that means I have no solutions. I have two parallel lines, which means same slope, different y-intercepts. And then I got the third situation, or third example, maybe not third situation. In this one, I've got two equations that are hard to compare. They're not both in the same order. So let's fix that. Let's take the second equation and put it into mx plus b. So get the m part, mx plus b, but I don't want 10y equals, I want y equals. So I need to divide everything by -10. And I'll end up with a negative over negative makes a positive, and 2/10 reduces to 1/5, and positive 10 divided by -10 is -1. So let's take a look at our slopes. Our slopes are -5 and 1/5. All those are different. Different slopes means one solution. And different slopes. And again, I don't care what they are today. I don't care what the point of intersection is. I just care if there is one. Okay, let's move to the second half of today's lesson. What if we don't want to rearrange? What if we could just look at patterns? That would be helpful to us, right? Mathematicians are always looking for patterns to simplify things, make things easier. So, if they're both in the order mx plus b, it was really easy to tell. We looked at our slopes. It's also fairly easy to tell if they are not an mx plus b, but they're both, that's their key, okay? They're both written in this format, ax, by, and c. Because what you can do is check for multiples. That will tell you the kind of system that you have. And when you look at your multiples, you're looking at your x and your y values, first of all. Okay, so for example, if I had x plus y equals 4, and I notice that all of my things are multiples. In other words, I have 2x, I doubled the x, and 2y, and 8. I doubled everything. This times 2 gave me this. Well, that would be the same line. It's got infinite solutions. It's just a different version of that line. Okay. What if, again, we'll take the nice easy one here, x plus y is 4. And I notice that my x's and my y's are multiples. So for instance, 2x plus 2y, but the number is not doubled. Well, that would tell me that they're parallel. I know they're parallel because my slope comes from my x and my y values. And again, the third situation is what happens if I double the x, but the y is not the same multiple? Well, if the x's and y's are not multiples, this was times 2, but this was not, that means there's only one solution. Okay, so let's take a look at some things. What do I notice? I notice I doubled and I doubled, times 2, but I did not double. So this is situation number 2. The x and y's are multiples. This is parallel lines. And I can do that without rearranging because I looked for my multiplier. Let's try the next one. Times it by 2, times it by 2, times it by 2. Hey, that's infinite. It's the same line, just a different version. Oh, sorry, in the first one here, we should say parallel lines, no solution. I mean, this is infinite solutions, it's the same line, twice. I'm going to try the third one. Times it by 2, yep. Times it by negative 2. Oh, that's not the same as 2, it's different. This is one solution. These are two different lines. It's the situation 3. The x and y values are not multiples. So if you work your way from left to right, you say, oh, my x is the same. Great. My y's are, oh, they're different. That's 1. My x is the same and the y's are the same. That's parallel. And if all 3 things are, it's infinite. And so I can get you guys a chance to try one here. We're going to make this system. So we've got an equation, x minus 4y equals 2. Write an equation that creates a linear system that has infinite solutions. Well, that means they have to all multiply. Now, I've been using number 2 because it's a nice easy one, but it doesn't have to be that. Let's choose number 5. So I'll have 5x minus 20y equals 10. That's all of this times 5, which means I've made the same line, just a different version of it. There's an infinite number of choices I can make here. Okay, let's try the second one. I want no solution. I want this to be parallel. To be parallel, the x and y's must be multiples, but only x and y. I want to go the same direction, but not be on top of itself. So I've got to pick a multiplier. Let's pick a different one this time. Let's pick negative 3. So I've got negative 3x. We're timesing this by negative 3. I'll get positive 12y and anything but multiplying by 3. Let's make that one 5. That's a different number. That's not times 3. That means I got parallel lines. And the last one, one solution, x and y not multiples. So let's change the x value. Let's change it. Let's change that to 2x. And if we keep the y the same, well, that means they're not multiples anymore. That means they're going to cross somewhere. Our slopes will be different. Our directions are different. Okay. Okay, that's it for today. Just a nice quick one today. I want us to be able to tell, do I have to worry about solving this? Or maybe it can't be solved. That would save me some time, wouldn't it? And so it's all about recognizing patterns. Look at your x's, your y's, and your numbers and see if there's multiples. Okay? You can do that sometimes by thinking the multiple, or try dividing them and see if the divider comes out the same too. Hey, give the homework a try, and if you're stuck, come see me.